Is your SQL query taking forever to run? Are you tired of waiting for results while your screen just sits there loading? Today, I'm going to show you how to reduce query execution time by up to 90% using a few simple tricks. Stick around because you'll be able to write faster, more efficient SQL queries by the end of this video. Welcome back to our channel. If you're working with MS SQL Server, you know how frustrating it can be when queries take too long to execute. Slow queries can not only hurt your productivity but also impact your application's performance, especially under heavy load. In this video, we're going to analyze why some queries are slow, use the execution plan to identify bottlenecks, apply proven optimization techniques to improve speed. The only tool you need is Microsoft SQL Server Management Studio, so open it up, and let's get started. Reduce SQL query execution time. Frustrated with slow SQL queries? SQL queries that take forever to run can be a major source of frustration, especially when you're working under tight deadlines or large data sets. Tired of waiting for results? Endlessly watching your queries load and slow down your work? It's time to put an end to that frustration and speed things up. Learn how to reduce query execution time by up to 90%. In this video, I'll share actionable tips and tricks to drastically reduce your query execution time and boost performance. Get ready for faster, more efficient SQL queries in this video. By the end of this video, you'll be able to optimize your SQL queries and get results faster than ever before. Demo, Step 1, write a slow query. Example of a slow query: select asterisk from orders where customer ID equals 123. Problem: the select asterisk pulls all columns, and SQL Server performs a table scan, reading every row in the table to find the matching customer ID. This results in slow execution, especially on large tables. Step 2, analyze with execution plan. How to run it: open SQL Server Management Studio. Before running the query, click on the Include Actual Execution Plan button in SSMS. This looks like a little icon with a graph. Then, execute the query. Expected result: you'll see the execution plan in the Execution Plan tab after executing the query. In this case, the plan will likely show a table scan. SQL Server reads through the entire orders table row by row to find the customer ID equals 123. Step 3, optimization techniques. Step 1, create an index on customer ID. By creating an index on customer ID, SQL Server will be able to quickly locate the relevant rows without scanning the entire table. Create index 9_customer on orders, customer ID. Why it helps: an index speeds up query execution by allowing SQL Server to look up values more efficiently, like using a dictionary instead of scanning through a book. Step 2, specify only necessary columns. Instead of using select asterisk, which retrieves all columns from the table, specify only the columns you need. This reduces the amount of data transferred and can improve query performance. Select order ID, order date, total amount from orders where customer ID equals 123. Why it helps: by limiting the columns returned, you reduce the data load and speed up the execution, especially for tables with many columns. Step 3, replace subquery with a join for better performance. If the original query had a subquery, replacing it with a join can improve performance. SQL Server can optimize joins more efficiently than subqueries. Original, hypothetical subquery example: select order ID, order date, select customer name from customers where customer ID equals orders.customer ID, as customer name from orders where customer ID equals 123, optimized with join, select O.order ID, O.order date, C. Customer name from orders O inner join customer C on O. Customer ID equals C. Customer ID where O. Customer ID equals 123. Why it helps. Joins are typically faster than subqueries because SQL Server can optimize the execution plan better, especially when dealing with large data sets. Performance test, before and after optimization. Before optimization, query 1, the query select asterisk from orders where customer ID equals 123, returned results with 0 milliseconds execution time. This is misleading, as SQL Server likely already had the data cached or optimized for simple queries. However, this is not an ideal scenario for larger tables. Query 2, the query select order ID, order date, total amount from orders where customer ID equals 123, took 73 ms to run. This is a more specific query, only fetching the necessary columns. This execution time is typical for a simple query when the database is not highly optimized. Query 3, the query select order ID, order date, select customer name from customers where customer ID equals orders. Customer ID, as customer name from orders where customer ID equals 123, took 186 milliseconds to execute. This query uses a subquery, and we see a higher time due to SQL Server having to execute the subquery for each row, which leads to inefficiency. Query 4, the query select O.order ID, O.order date, C. Customer name from orders O inner join customers C on O. Customer ID equals C. Customer ID where O. Customer ID equals 123, executed in 0 milliseconds. In this case, SQL Server likely optimized the query very efficiently, as it can use indexed columns and internal optimizations for joins, resulting in minimal execution time. After optimization, expected improvements. After applying optimization techniques like indexing, the query performance for all queries should improve. Subqueries, query 3, will benefit the most from optimization because replacing them with join, as done in query 4, will drastically reduce execution time. Indexing on frequently queried columns, example customer ID, will also significantly reduce the query time for the select queries. Troubleshooting, common issues and best practices. Common issues, outdated statistics. SQL Server relies on statistics to determine the most efficient way to execute a query. If your statistics are outdated, SQL Server might not use the best index or plan for the query. Solution, run update statistics on tables to ensure SQL Server has the latest distribution of data. Subqueries versus joins. Subqueries can often lead to slower performance because SQL Server has to execute them for each row in the result set. This is especially true when using subqueries in the select clause, like in query 3. Solution, replace subqueries with joins where possible. Joins allow SQL Server to optimize the execution plan better. Over-indexing, having too many indexes can slow down data modification operations, insert, update, delete, because SQL Server has to update all indexes after each operation. Solution, keep a balance. Too many indexes can be counterproductive, so aim for no more than 4 to 5 indexes per table. Small tables, if the tables involved are small, example only a few hundred rows, SQL Server might choose a table scan over using an index, which can result in fast execution times despite inefficient planning. Solution, make sure to test performance on real-world data with larger tables to get accurate execution times. Best practices, indexing, always create indexes on columns used in where, join, and order by clauses. This will significantly improve query performance. Use of join instead of subqueries, whenever possible, Use join for better performance as it allows SQL Server to perform more efficient query planning. Regular maintenance. Regularly update statistics and rebuild indexes to maintain optimal query performance. Conclusion. In this demo, we saw how query execution times can vary before and after applying optimization techniques. The biggest improvement was seen by replacing subqueries with joins, as seen in Query 4. This drastically improved performance by reducing execution time. Indexing the customer ID column helped SQL Server optimize the retrieval of data more efficiently. The optimization resulted in noticeable reductions in query execution time, leading to better performance for the database queries. Call to action: like, subscribe, and share. If you found these tips useful, hit the like button and subscribe for more SQL tips and tricks. Comment below. Let me know in the comments if you're facing any specific SQL performance issues, and I might cover them in the next video. Apply these techniques, try these optimization techniques in your own SQL queries and see how much faster your queries can run. Stay tuned, keep an eye out for more advanced SQL optimization strategies in upcoming videos. Thanks for watching.